This lesson is on perfect squares and square roots. If you could label your paper perfect squares and square roots. The objective is to be able to understand what a square root is, and then how to find the square root of a perfect square, and how to approximate the square root of a non-perfect square. So perfect squares, what are they? A perfect square is a product of two equal integers. So, for example, when I multiply 2 times 2, I get 4. This means that 4 is a perfect square because when I multiply 2 by itself, I get 4. Another example, if I multiply 3 by itself, that's a product of two equal integers. 3 times 3, that equals 9. So that product is 9, so 9 is a perfect square. Another example would be if I was to multiply 6 times 6. So I'm multiplying two equal integers together. I'm multiplying 6 and I'm multiplying 6. So they're the same integer and I'm multiplying it. So that result, 6 times 6 is 36. So 36 is a perfect square because I multiply 6 by itself to get 36. Sometimes what you'll see this written as is 2 squared equals 4. This means when I multiply 2 by itself, I get 4. Here you might see this written sometimes as 3 squared equals 9. This just means 3 times 3 is 9. Same thing with 6 squared equals 36. This power of 2 just means I'm multiplying 6 by itself twice. So it'll be 6 times 6 gives me 36. So those are what perfect squares are. And if you look over to your right there, where I have square roots of perfect squares, I have a list. There's sort of two things going on here. I have a list of perfect squares. So that list of perfect squares is over here on the right. So 1, 4, 9, that's 16, 25, 36, 49, 64, 81, and 100. Those are the first few perfect squares that we have. What is special about perfect squares is that we can take the square root of a perfect square. So if we look, we have square root of 1 is 1. Square root of 4, this is one that I really want to kind of start looking at here with you, is the square root of 4. What this is asking me is there a number that I can multiply by itself to get me 4? And you think about it, and we kind of went over at the beginning, 4 is 2 times 2. So I can take the square root of 4. I am going to get just one of those 2's out. So the square root of 4 is 2 because I multiply 2 by itself to get to 4. So really when you're taking the square root, it's asking you what number are you multiplying by itself. So here when I take the square root of 4, I get 2 because I'm multiplying 2 by itself to get 4. Let me show you the square root of 9. So the square root of 9 can be broken up as 3 times 3. In other words, if I multiply 3 by itself, I get 9. So the square root of 9 is 3 because that's the number I multiply by itself to get 9. And then if we look, there's some more here listed here for you. So square root of 16 is 4. Again, if I was to multiply 4 by itself, I would get 16. Square root of 25 is 5, because if I was to multiply 5 by itself, I would get 25. Square root of 36 is 6, because if I multiply 6 by itself, or if I do 6 squared, I get 36. Square root of 49 is 7, because if I multiply 7 by itself, or if I do this 7 to the power of 2, I get 49. Square root of 64 is 8, because when I multiply 8 by itself, I get 64. The square root of 81 is 9, because when I multiply 9 by itself, so in other words, when I do 9 squared, I get 81. And the last one, the square root of 100, is 10, because when I multiply 10 by itself, in other words, when I do 10 to the power of 2, when I square 10, I get 100. So those are the perfect squares, and this is what it means to take a square root. When you're taking a square root, you're just seeing what number multiplies by itself to get me that number that's underneath the square root. So let's practice identifying. Is 16 a perfect square? So in other words, could I break 16 up as some number times itself? So for 16 would be 4 times 4. So yes, it is a perfect square. And you could have just checked, if I go back for a moment, you could have just checked our list of numbers. So 16 was in our list, it was right here. So it is a perfect square. Is 21 a perfect square? Well, if I was to break apart 21 into its factors, so if I was to say what two numbers multiply together to get me 21, I could say 1 and 21 get me 21, but those aren't the same. Let's see if we could factor 21 in another way. We could say 21 is 3 times 7, but those aren't the same. So since those aren't the same, 21 is not a perfect square. So we will say no. It's not a perfect square because I can't break apart 21 using some number times itself. So 21 is not a perfect square. Another example. So is 4 divided by 9 a perfect square? So what we'll do in a fraction, we'll say, can I break apart 4 using some number times itself? And can I break apart 9 using some number times itself? So 4, we've seen that one a couple times already. That's 2 times 2. And 9 is 3 times 3. So since 4, this means that 4 is a perfect square. And 9 is a perfect square. So that means since both of those are perfect squares, 4 9ths is a perfect square because the numerators are perfect square and the denominators are perfect square. So since both the numerator and the denominator are perfect squares, that means 4 9ths is a perfect square. So you're just checking, are both the numerator and the denominator perfect squares? Again, if you want to make life a little easier, just have this list of perfect squares up to 100. Have that out next to you as you're working through this, and it will help you be able to pretty easily identify what your perfect squares are. So finding a square root. So we just practiced identifying what was a perfect square. Now let's practice finding a square root. So here we got the square root of 2,500, and this one's not anywhere in your list. So I'll help you with this one. So can we break up 2,500 as some number times itself? This would be 50 times 50. So the square root of 2,500 is 50. The square root of 144. So you're going to break 144 up into, you want to try to break 144 up into some number times itself. So this would be 12 times 12. So your answer here would be 12. And if you're not sure, guys, you can use the calculator. In MathXL, you have calculator. Here's how you would do this in the calculator. You could type 144 and then click the square root button. Here's the square root. Click it, and it will give you 12. So if you're not sure if something's a perfect square, you can always use your calculator in MathXL to help you there too. So number 3, the square root of 64. I want you to try that one. So how would you break up 64? So the square root of 64, what does that equal? So hopefully you gave this one a try. If I wanted to break up 64, it'd be 8 times 8. So my answer here would be 8. Because when I multiply 8 by itself, I get 64. The next 3 that we're going to go over, similar idea to what we just did, but now we have a fraction. So basically, we'll have to take 2 square roots. We'll have to take the square root of the denominator and the square root of the numerator. So let me show you an example with 4. So Notice I have 100 divided by 900, and that's all underneath the square root. So I'm first going to take the square root of 100, then I'll take the square root of 900. So the square root of 100, this is 10 times 10. So this is, the square root of 100 is 10. Then for the square root of 900, so the square root of 900 is 30 times 30. And remember, if you're not sure, open your calculator in MathXL. You'll type 900 and then hit the square root key, and it can do 30. This means if I multiply 30 by itself, I get 900. So this will get me 30. So I could rewrite this fraction, square root of 100 divided by square root of 900, as 10 divided by 30, but that reduces. Those are both divisible by 10, so this will just be 1/3. 10 divided by 10 is 1, 30 divided by 10 is 3. Number 5 will be done very similar to how we did number 4. So we'll start with the numerator, and then we'll take the square root of that number, then we'll take the square root of the denominator. So in number 5, we have square root of 9 over square root of 225. So we'll handle these separately, just like we did in number 4. The square root of 9, well, remember 9 is 3 times 3. So the square root of 9 is 3, because 3 times 3 gets you 9. And then the square root of 225. Again, this might be one that you're not familiar with, and you can use your calculator. Remember, you're going to type 225 and then hit the square root key. And when you do that, you would get 15 times 15. So the square root of 225 is 15, because when I multiply 15 by itself, I get 225. So that means that the square root of 9 divided by the square root of 225 reduces to the square root of 9, we said was 3, and the square root of 225 is 15. Notice I have 3 divided by 15. Those are both divisible by 3. 3 divided by 3 gets you 1. 15 divided by 3 gets you 5. So my answer here is 1/5. So I'm going to go on to number 6. Number 6. So I have the square root of 9 divided by 4. Notice those are both underneath the radical. So we'll do it the same way we did 4 and 5. We'll do the square root of 9 divided by the square root of 4. So I want you to try this one. So try to find the square root of 9 and then try to find the square root of 4 and write that as a fraction. So pause the video and give it a try. Hopefully you paused the video and gave this a try. So in number 6, the square root of 9, the work I did in green for that one. 9 is 3 times 3, so that means the square root of 9 is 3. Then I did the denominator. Square root of 4, well, 4 is 2 times 2, so that means the square root of 4 is 2. So then I could write my fraction as 3/2, because square root of 9 is 3, square root of 4 is 2, so my answer here is 3/2. So when we're working with square roots, we're not always going to end up with whole numbers when we take a square root, because not every number is a perfect square. So we will have cases where we're taking the square root of a number that's not a perfect square. If that's the case, then what's going to happen when you take the square root in your calculator is that your answer is going to be a decimal. So for example, if I was to take the square root of 40, well, 40, when I take the square root, I get this decimal, 6.3245. So 40 isn't a perfect square. It would just mean that I would have to multiply that decimal by itself to get me 40. So it's not a perfect square because I don't have a whole number times itself to get me 40. So I've mentioned a couple times that you're going to use your calculator to help you in MathXL, and this is the way that you'll use it. And again, I've mentioned this a couple times. So first you're going to type the number underneath the radical. So in this example up here, I would type 40 first because that's the number underneath the square root or the radical. And then we're going to click the square root button on your calculator. And in MathXL, this is your calculator, right? The one that I have that I'm highlighting here in blue. This is your calculator. The square root key is this thing right here that looks like a little check mark that I'm highlighting in green. That is your square root button. So that's the button you're going to press when you want to take a square root. So let's look at examples, some examples where we don't have perfect squares underneath the square root. Evaluating non-perfect squares. So what we'll want to do is we're going to just use our calculator to do this, and we want to round to the nearest hundredth. In other words, remember, hundredth means 2 decimal places. So I wrote out the instructions for the first one. So the square root of 50. So you would type 50 in your calculator and press the square root key. So 50 in the calculator, press the square root key. You get 7.07. So that's exactly how you're going to do all of these. So square root of 8, if you do that, 8, hit the square root key, you get 2.828. So that 8, the second 8 is going to round the 2 up, so it's going to be 2.83. And if you do the same thing for number 3, square root of 14, you're going to get 3.74. So those are your answers for those. So what we're going to see next is what happens when we add square roots together. Simplify by adding or subtracting. So here I have square root of 121 plus the square root of 36. Square root of 121, this is 11 times 11. So square root of 121 is 11. 36 is 6 times 6. So that means the square root of 36 is 6. So this will be 11 plus 6, which is 17. Number 2, simplify square root of 169 minus the square root of 16. So this one I'll do it showing the calculator. I'm going to do 169 and hit the square root. Oh, that's 13. So this means 13 times 13 is 169. So I'm going to do 13. And then I'm going to break up 16. So 16 is 4 times 4. So this means I have 4. And then I want to subtract it. So I'm going to bring this sign down. So 13 minus 4 gets you 9. So my answer here is 9. So just make sure if you're adding and subtracting, make sure you bring that sign down after you take the square root. So you have a square flower garden that has an area of 400 square yards. What is the length of one side of the garden? So here what they're asking you, they're telling you is you have a square. So here's my square. This is my garden. The area of my garden is 400 square yards. So they want to know what's the side length of one of your sides of your garden. So remember, in a square, the sides are the same. So we could call them S and S for side. Your sides are all the same. So if I want to do the area formula for a square, remember it's going to be area equals side times side, or S times S. So the area here is S times S, which is S squared. Because I called my side lengths S, because I don't know what they are. Now I'm going to plug in, I know the area is 400. So I'm going to plug in 400 for A equals S squared. To get rid of the power of 2, because I just want this to say S, I don't want S squared, I want S. So we're going to take the square root of both sides. So the square and the square root cancel each other off. So every time you see a power of 2 and you're solving, you're going to take a square root. Whatever you do to one side, do to the other. So this gets me S by itself. Now, pull up your calculator. Square root of 400. You might not know that off the top of your head. So let's just check. Square root of 400. Hit the square root key. It's 20. So this means 20 is the length of my sides of my square. And this should be yards. So 20 yards is the length of a side of my square. There is an assignment for you to do in MathXL. It's called Simplifying Radicals Skill Work. It's just a handful of problems for you to try. Just practice taking square roots. Again, you have the calculator in there. If you're not sure if something's a perfect square, check it in the calculator that you have in MathXL.